And as a result, my OBS Studio stopped working correctly. So then I had to like upgrade that. It's one of these great snowball effect of stuff, which is always fun and exciting. So I've posted up on LMS. There are actually, for today, there's a 6A, 6B, and a Project 2 Apple Picker rules and suggestions. Let's see where we go. And I think I'm tempted to even kind of do things in a little bit of a different order. Maybe we'll do 6B first, and then do 6A. We've been doing so well with moving things around on the screen. We had physics dropping apples, and we had our Lego crook moving side to side. The two of them aren't hooked together. We'll talk about that, how we get the Lego crook or the apple the bomber, or whatever it is, to drop the apples as opposed to them being two completely distinct events. But the third big piece, as far as movement goes, is ultimately the player's piece of things. How does the player move? The player basket, the catcher, the whatever it is that we want on the screen. How's that going to happen? So I wanted to talk about basic input, right? This is going to be the user doing something, and not like the cheesy way of just doing it in the user interface, click a button and sort of stuff. Can I get, if who's ever online, can you let me know that you can hear me? Say something?
Yeah.
Okay, great. All right, and I can hear you. That's good. Just wanted to double check on that. Now that I'm not using my headset anymore. It seems to be working out reasonably well, which is good.
I will say, last week, like when you were pacing over to the other side, it got hard.
Can duck down? The volume wasn't as good?
No, it was just hard to hear you as you were pacing around. Like you would move, and then I couldn't hear you anymore. And you'd come back and I could hear you.
Okay, I'll stop pacing, I guess. I can't help it. I'm just.
Yeah.
I'm here in person. I feel like I have to, All right, I'll stand behind the screen here. So, two basic types of input that are built into PCs. This is like without the external benefit of joystick controllers or things like that. We come to expect mouse input and keyboard input from all of our computers. Who's I mean, if you don't have a mouse, at least you have some kind of trackpad. And most of the time, the moment you're in front of your own desk, you plug in a mouse almost immediately. I find it's not too often that people exclusively use a trackpad, but we'll consider trackpad and mouse. They're the same kindred sort of controllers. And of course, keyboard input. Certainly anyone who's a tournament gamer or professional gamer or any kind of gaming league, it's always about keyboard, one hand, mouse in the other, sort of thing. And so they're the not holy trinity, the dynamic duo of input, we'll call them. I don't know. So the mouse. What can happen with a mouse? You can click the mouse button. You can hold the mouse button down. You can release the mouse button. Or, more interestingly, in most cases, get the current position of the mouse and also whether or not you're doing things like dragging or selecting, so sort of higher level interactions with the mouse as well. That's another class of things. There's sort of basic things like just a click or a move, but then also more sophisticated things like a drag or a select. Keyboard input, pressing a key, holding a key down, releasing a key, and of course the identity of the key pressed. That actually has a lot in common with the mouse buttons as well. So we can do things like click the mouse button for the first time, hold it down, and release it. So there's buttons, sort of button class things and motion kind of based things. They are our input. So specifically, we'll look at keyboard input. And the funny thing is, I guess, they of course always want you to see this stuff and cover it first, talk about keyboard input. But the Apple Picker game will not be using keyboard input, so I'll just warn you right away. We're going to kind of try to use just really the mouse and not even any mouse clicking necessarily. So even though I start out with the keyboard input, we sort of reserve that for special occasions. So when you do get keyboard input, though, you get a key code which stores preset values for any key on the keyboard. Right, so you will see this capital key, capital code, special keyword that will allow you to figure out, when you are trying to figure out what key is pressed. You're saying keycode dot space, keycode dot A, keycode dot right arrow. So that's one to kind of just keep in the back of your head. When you refer to key codes or you refer to keys, you figure out what they are according to their key code. So when you get input, and you will see this input dot, so it's an input library or an input namespace that contains most of our input functions. And one of the basic ones is input dot get key. See, there's going to be lots of get functions. And we tell it what key we want it to get. So we specifically ask for a certain key. So we say, okay, let's find out something about the space key. This particular function says will return true every frame that the space key is pressed. So it's sort of designed to be used in update, and it will return true so long as the space bar is pressed. The trick of that, of course, is that, as you'll remember, update can happen at some seemingly not random, but non-uniform rate, and it can vary according to how fast someone's computer runs or how fast their graphics card or how fast their display refreshes. So in one system, it might be happening at 144 times a second, it might be 60 times a second. A really bad graphics card on an older machine might be 30, who knows, even slower. So be careful about doing things when you just say things like input.getKey. It's best for purposes of like, oh, is the space bar held down? And if it's down, do something that's not rate dependent. You know, maybe there's like, they have shields on, things like that, where it doesn't matter how often you press it, just matters that it's pressed. Be careful with that thing. On the other hand, we have get key down, which also is usually called inside of update. We do a lot of our input, almost all of our input really inside update, because it makes it feel nice and responsive to the user, right? Something changes on the screen, they have an impact on it, right? So it's important that way. So get key down looks similar, but it has the down part on there. We ask it what key. It returns true on the first frame when the key was pressed, in this case, the space key. So this one's, you know, you want to press fire, you have to press the button once every time you shoot a bullet, sort of thing. And you check it inside of update, and it will return true, and then it will stop returning true as long as it's held down. So it's a great way to avoid just firing like mad, that sort of thing. You also have get key up if you're interested in having something happen when a key is no longer pressed. So if you turn the shields off when the key comes up, you can do that. It's nice to know, okay, do this when the key goes down, do this when the key comes back up, or just poll to see, is it happening all the time, right? Pretty simple, usually just winds up inside an if statement inside an update. So imagine key down, they hit the space bar, the character on the screen jumps. They only get one jump per press of the space bar. Okay. The mouse with buttons, right? Each mouse button has a different default index. It's designed around this kind of weird, slightly weird rule that, or thought that once upon a time there were mice that only had one button. So 0 is the left mouse button, the dominant button. And then 1 was the right mouse button. So we had left and then right, and then 2 being the middle mouse button. So 0, 1, 2. So kind of, you know, not all mice had 3 buttons. So we just assumed left and right were the first ones, and then 2 is the middle one. So it's a little bit odd. After that, then it just becomes the Wild West, you know, how you're naming all your buttons. It works similarly in terms of get mouse button, just like get key. Returns true every frame that a certain mouse button is pressed. It's not a key code dot mouse left. Maybe would have been nice, arguably. That would have been a cool way to do it. But they decided get mouse button and then the number of the mouse button. And we have similarly get mouse button down 0 and get mouse button up 0. So you can tell when did they click, are they holding it down? So you can do interesting things like have one of the mouse button be, you know, a shield and the other one you tap to fire, things like that. All kinds of interesting combinations. So similar, you want to start the game, you want to wait for a mouse click, you can do something like this. Wait for that first time that the mouse button is pressed, go ahead and start the game. Now, that's what we would refer to as polling input. Anybody heard the term polling before, right? The idea is that you ask continuously as things are going on. You're continuously checking. You're polling it. You're asking it. Is it time? Are you there? Are you pressed? Are you there? You know, are we there yet? Over and over and over and over again. So it can be less than efficient. It can be time consuming. But there is an alternate, different way that Unity has event functions, just like we have update and start. We start to get into the event functions, where you might have an on mouse down event, which is when the left button is pressed over a certain object. So on events are object specific, whereas input events they're just polling the state of the hardware. So with on and events, they become object specific. So then we can start to see, okay, was this object clicked on? Was this object selected? We don't have to worry about figuring out all the picking problem ourselves. You know, if this is computer graphics or we're doing our own engine, we have to figure out, okay, how do we pick an item on the screen? How do we figure out what it is? You clicked in this location, what's really there? All that. Unity will take care of that for you. So if you wanted to say, oh, they clicked on the key that was on the screen, you just have an on mouse down event on a component on that object. And as long as it has a collider, it's going to be good to go. Does it need a collider? I think it needs a collider, but it might not. We'll double check that. So we have a bunch of different Unity events on them. On mouse down, on mouse up, on mouse enter, and on mouse exit, which just means if you hover over that or you move the mouse on top of it. On mouse over, let's see, enter, exit, over, drag. So if the cursor is pressed down after clicking the object and it's moved, or on mouse up as button. Trigger only when the cursor is released while still over the object that was clicked. So we have all these kind of different permutations. Lots of different flexibility on that. Usually just a few simple ones are enough to do it. All right. Now, on our project, we're going to focus on this one, input.mouse position. So we can figure out, as the user moves the mouse, it's not just a matter of did they move left or right, how much did they move. It'll give us an absolute position on the screen where the mouse is. Very useful. To understand that, though, we have to know a little bit about space as far as the game goes, as far as Unity goes. Because a mouse, the way that a mouse device works is normally there is some kind of coordinate on the screen. Right? There's a pixel coordinate on the screen or a device coordinate on the screen that the mouse location refers to. As you might imagine, that's very different than the space in the world that you might be looking at in your game, or the space in the window that you happen to be having open in Unity or on the desktop. So we have to figure out how to convert between different things. How does that map from one space to another? We've got three main spaces in Unity, or three kind of coordinate spaces. The first one, as far as the mouse goes, important one to know about, is screen points. And this is starting at 0, 0 in the bottom left corner to screen width and screen height in the top right corner, defined in pixels based on the screen resolution. So you can ask for something to be in screen points. You can look at something in viewport points, which are something called normalized coordinates. I mean, they go from 0 to 1. They are resolution independent. So they start at 0, 0 in the bottom left corner, go to 1, 1 in the top right corner. The nice thing is that it always maintains that same set of relative values regardless of resolution. So if you scale a window or something like that using the viewport coordinate system, it will just always give you 0 to 1. Now, world points go from 0, 0 at normally the center of the camera to negative and positive values to the left and right based on Unity world units. Right? So now we get into the meters inside of Unity sort of thing. That can change based on camera size, zoom, where you are. Right? You zoom in, suddenly a meter is a lot bigger because you're close to it. You zoom out, and so on and so on. Unity provides a bunch of different ways to convert between them, thankfully. We can go from screen to world points, we can go screen to viewport points, world to viewport points, world to screen points, viewport to world points, viewport to screen points, all those fun things. For our purposes, you're not going to have to worry about most of those. It's going to come down to just basically one of them. So, to do what we want to do, we're going to attach a new script to an object, and then on every frame, every update, find the position of the mouse and set the object's position to match. So we want to just move an object around in the world according to wherever the mouse is. In the game, we're only going to use left and right because our baskets can only move left and right across the bottom, but we're free to use it, go across the whole screen if we want. So the challenge is that the mouse's position starts off in screen point space, while the object's position is in world point space. So here's a few of the key players in our discussion here, or our problem here. One, input.mouse position. We can get the mouse's position, and it does show up as a 3D coordinate, which is interesting. You might wonder, what is that Z coordinate? Most of your displays probably are two-dimensional, like mine. Then we're going to also be concerned with the transform.position, the object that we want to move on the screen or in the world. And the one transform, the one conversion that we're going to use for this is going to be screen to world point. You'll notice we also reference a camera to figure out how that goes, because there may be multiple cameras on the screen. You can do things like divide up, have a mini map, have a couple of different cameras mapping to different ports of the viewpoint, all that parts of the viewport, and so on and so on. So we generally have to say, what camera are we looking through? And then what type of coordinate conversion are we going to do? Screen to world point. All right. So this is probably one of the most important key slides you can refer back to, snap this code, see in the presentation, about how to move an object with the mouse. And I just find it seems like every semester I try to come up with a version that's slightly more optimized, or a version I like more, but there's lots of subtleties to this that you do. But the basic idea, have an object tracked with the mouse. We can combine the techniques from the previous slide. It involves getting the mouse position. See the first line here inside of update, we just have a vector 3, so we're going to have 3 coordinates. That's going to be the mouse position. Mouse pos equals mouse input.mouse position. And because we're going to do some conversion, we're going to have sort of a temporary, say, okay, what's the new position we want to move the object to? So we're going to allocate that up ahead, declare that up ahead here. And the first thing we're going to do is say, okay, let's convert the mouse's position to a world position. So we just pass that vector 3 into our function mentioned, camera.main.screen to world point mouse position, mouse pos. And set new position equal to that. Now, these next 2 pieces are important for a couple of different reasons. One, because of the type of control we want to do in our game, which is we only want left and right. So we say, well, we don't want to modify the object's y position, right? We want to, hopefully, our goal is to say transform.position equals new position. So we grab the object's y and we put it into the y position there. And we also do the same for the z position. Because the mouse does have a different z. Like everything in there, and it winds up being, the z position will be the camera's z position. So the mouse inherits the camera's z position. So we wouldn't want to move the object to the camera's z position, or else we'll have the inside my own head problem where you can't see yourself, right? So we want to avoid that. And we want to pin the object to its y position. We don't want it moving up and down the screen. We only want it moving left and right. So we really are just interested in the x position. So that's one way of doing it. Using our familiar, our old, brute force scripting kind of thing, where we say we go ahead and change the position by hand. Now, if that's too plain for you, or you really want to play by the rules of only use translate to move objects around, and you don't want to just immediately set that, of course you can do different things like what's down here, where what I did is I found, okay, let's get this new x translation, because that's all I'm interested in. I want to translate this object in x, and I could say, well, here's the mouse's x position, that's where I want to go to, and here's the object's current x position, that's where I want to move from. The difference between those two is how much I want to translate by. Right? So I can move relatively, use my translate, which is a relative motion. I can just tell it, okay, translate this object according to this vector 3, which is just using that x offset. So we have two different types of things here. One, which was an absolute positioning. I said, okay, here's the new position I want to put it to. Blam, put it in there. This equals that. The other one is a relative motion, where I figured out, okay, here's the position of the mouse relative to where the other object is, and move it relatively. The end result's the same, right? Exactly the same. So depending on your circumstances, choose which you like. So this is a good point to actually try that. So let's go to our game and our scenes, and we'll go with apple tree. Oh, what happened here? Did I not save that? Did my machine crash before I saved that? Could have been. I've had some overheating issues with my computer, and I think this is one of the situations where it's always good to say save and upload it to the cloud, and I didn't do that. So that's okay. I will create yet another apple tree. We'll go to the canvas. Let's move this. We'll choose this button. Get it out of the way. Put that down here. And for now, we're just going to worry about our thing that we're going to use to catch other things. So we'll grab a minifigure that we want to have the one who's going to be the player. And what the heck, I'll use the pizza guy. So I'm going to go zoom back in on the camera. I'm going to grab my pizza guy, and I'm going to throw it in the scene towards the bottom there. Okay, so now the pizza guy is going to be the player. And we'll go ahead, click on that. And player. And we will add a component called a player controller. Probably a good idea, since we're going to have multiple games in here, choosing something generic like player controller wasn't the best choice on my part. I should call it something like basket controller, or player apple picker player controller, AP underscore player controller. Who knows? Maybe I'll go back and change that later, or maybe I'll accidentally delete the whole file and start over again. But let's continue on through. So, in the interest of time, I'm going to come back over here. I just remembered, I did this to avoid letting people cut and paste code so that they would be forced to have to do it. And so now I'm going to be stuck living by my own example. So let's go for it. We'll say we have a vector 3, which is our mouse position. Vector 3, which is our target position. And we will say mouse position equals input dot get mouse position. And our new position, or our target position, equals camera dot main dot screen to world point of our mouse position. And sometimes it's fun at this point just to go ahead and say, well, let me print that out so I can generate lots of spam my console windows. Like, if you're really curious to see what that maps to, go ahead, print that out. You'll spam your console window and it'll just be like 144 times a second. Just be a wreck. If we don't want to do that, we can take the next logical step and say, okay, target position dot x equal, we want the target position x to change. We want y equal to transform dot position dot y, because we don't want to change the y position, and target position dot z equals transform dot position dot z. Now I probably could have even done it the other way around and said, okay, here, let's do it fewer lines, is to say target position equals that, and then say target position dot x, because that's really the only one I'm interested in from the mouse. So why don't I do that? That's always save a line of code when you can. Target position dot x. Nope. We wanted to say transform. No, what am I doing here? Target position equals transform. Okay, now yes, I had to do the next step here. Yes, target position dot x. This is what I need to do. Can I do that? Yeah. So now I've gotten the transform position over here, and now I just grab just the x position from what's returned there. And now I can say transform position equals target position. So we'll save that. And voila, our player will track, and you'll notice it will go way off the screen. Subject to being in that window, though, right? It has to be, the mouse has to be within the game window. Right? So it will go outside of here, but it won't go totally crazy. Notice it doesn't matter if we're at the top or the bottom. As we get even more sophisticated, we can do things like scale that, or also Maybe we want to clamp the position. Maybe you don't want it to go off the screen. So we can always decide as part of this to get a little slightly more sophisticated and say, you know, clamp this, right? F. Clamp that position to some set of values, negative 5, F, 5, F. Right? Capital F M there. Why didn't that capitalize? M A. What? There we go. So now I won't be allowed to go off the screen. Boom, boom. Probably even too close, right? It's 5 up and down, and it should have been like 8 left and right. But for purposes of the demonstration, it's exactly right. All right. Now, Unity also has it has actually 2 different input systems. There's a more modern one that you can use either of them. This is kind of the classic input system versus the newer input system. The newer input system is potentially more powerful, but involves a little bit more setup with regards to like, you know, kind of accommodating combinations of different controllers and whether or not you're, you know, deploying on the PlayStation 5 or the Switch or the, you know, all these sorts of things. You can kind of further virtualize a lot of your controls. We're going to use the slightly older version, which still allows for a good deal of virtualization of controls. So one of the key themes I like to go with is never hard code key presses. So if you're doing say a WASD controller, everybody knows what I mean when I say WASD, right? You know, W forward, A backwards. W forward, S backwards, A, D left and right. You should never actually query those keys. Never actually look for those keys. Instead, you should use one of the virtual axes or buttons on Unity's input system for you. So it can kind of abstract some of these things, like create an event or a fireable event called fire1, fire2, or jump, or even refer to horizontal and vertical joysticks that are matched to combinations of keys and Joy-Cons and so on. The nice thing is, and we won't do this in the Apple Picker, but in subsequent games, if you do it right, without you even knowing it, you can use the WASD keys, and then I can plug any number of my different controllers I have at home, and they'll just automatically work. And that's a testing criteria plus 1 point if I find I can do that. So we won't design with that in mind, but if you do it right, it's a bonus point you'll get. Or maybe you design with that in mind now that you know that's a bonus point available for that. So for each game of game 2 and 3, if, I won't tell you which controller, maybe one day I'll choose one day I'll choose the other. But if you use your input system right, it'll just magically work. So we typically use the horizontal and vertical joysticks, which are analog sticks, or can be programmed to be analog, and they return -1 when you are moving either down or to the left, or 0 when not moving, or 1 when moving up and to the right. And they can be analog anywhere in between, right? So you can imagine, you know, a thumbstick, hard right, hard left, or excuse me, hard left is -1, hard right is 1, and finger off the stick, that's a 0, right? Rest. Mouse X and mouse Y, as far as the input system, is a little bit different. That returns the amount of change in that value since the last frame. That's a bit more complex. We can get into that eventually. I don't know. I'm not a huge fan of that. But for this next project, using input dot mouse position is what we'll wind up using. So if you do want to use any of the virtual buttons, though, like space or fire or jump or things like that, we use input.get, like .get mouse down, or get button down, which is similar, you know, it's going to be triggered on that update in which it was pressed down. You say get button down, get button up, similarly. The more interesting ones, though, are these joystick-like values using input.getAxis. And you can have more than just horizontal and vertical as well. You can have, you know, multiple sticks and so on. But we'll just use the main horizontal and vertical axes as we get into our shoot 'em up games and our platformer and so on. And so for that, you get, you know, a -1 to +1 for your X movement. Say input.getAxis horizontal, just refer to it by its name. And then you can decide, what exactly do you do with it? Here's a common one. So you say, well, okay, I want to set it according to some speed. Maybe you're using that as a throttle, basically. And you scale it according to delta time so that, you know, maybe you're translating your object on the screen according to that. Right? So we could actually give this a try. Oops. Why not? So in this case, we will grab that code. Whoops. Let's grab that code. And we'll see what our friend will do when we do that. So here's what I'll do, is I will get the vertical. And so I'm going to change the Y position according to, what happened here? Oh, yeah. That's the one thing about cutting and pasting. There we go. Thank you very much for noticing that before it drove me too crazy. My eyesight is just not great on the laptop. Okay, so the Y is going to move up or down depending on vertical movement scaled by our time delta time. Still which? Still in the, oh yeah, you're right. No. There we go. And let's see, when doing something like this, it's always a good idea. I always like to go back and review to make sure that I'm not just continuously overwriting something here versus down here. And I think we're okay because since we're maintaining the object's position here, we should be good to go with regards to moving it there. So I think this is going to work. Oh, well, it's debugging or attached for debugging here. All right. So left and right, and up and down. I keep wanting to do my A and D key to be left and right, but so one of the things you'll notice is it kind of ramps up and it slows down. Even though I'm using just keys, which of course are just binary values, it has a very analog feel to it. And that's because the input system allows you to kind of further virtualize the way that these inputs work and have them speed up and slow down, interpolate in and out with regards to how they report their values. So let's go to properties. Wait, where am I? Project settings, input manager, axes. And this is where your normal input system is kind of set up. So in project settings, input manager, and we can see here is our horizontal. Let's go to our vertical. And we'll actually see that there will be two different settings for it. We're allowed to mount multiple things into the same axis. So here we have one set. So our down and up buttons and S and W for our WASD keys. We have gravity, dead, and sensitivity, which determines how quickly it will respond. So when you go from full on, full off, or the W key to the S key, it will actually ramp down and ramp back up in the opposite direction. That will kind of center itself and so on. So you can give it, you can wind up with a kind of a, sometimes it feels a little bit floaty that way if you're, and let's see, and the other one similarly might have different settings for an actual joystick axis here. Right? So it has a joystick axis and keys mapped to that one. Now, something you can do, if you don't like that floatiness or that kind of analogness to it, you can ask to just get axis raw, which will give you the raw value. In this case, since it's just the keyboard values, it will be -1, 0, or 1. And it'll feel a lot more snappy. I think that's the best way best term to use there. I'll show you that. All right. I don't know how much you can get the feel for that, but it just responds a lot quicker. There's no slowing down, and it just immediately changes direction. Okay. All right. So we've conquered left and right. We have the input system up our sleeve for our next projects. So, kind of the next piece is to try it on your own. If you didn't immediately follow along, or you're just looking at this, definitely some incremental change you should try immediately. Is go ahead and do that. So it's not homework you can test it on, or you're gonna have to look for the response to that. But that's one piece. You should definitely get that working. All right. That has us covered for. Yeah, everything else will be a variation on those things. We'll get into things like we'll do rotations with the mouse, or even kind of different types of controls. You can imagine you could move with a stick. You might, in some cases, if you have a top-down type of game, kind of a 2D top-down, you're going to move forward, backward, left, and right, kind of move around in the screen. Versus if you had a tank or a car where you might rotate. Well, cars don't really rotate. But you might have something where you're steering and going forward and back as opposed to translating all over this screen sort of thing. We'll talk about different ways to simulate those types of motions as we get into the next game beyond that. So that covers us pretty well for that. Now, next up, we're going to move back again. Content. All right, so we covered that. Now let's go up to A. Collections, sprites, and prefabs. Dealing in multiples. I like to refer to the multiples lecture. So you have lots and lots of different things that you want to keep track of, or you want to instantiate lots and lots of things. Or even in the case of like sprites, so when I created my sheet or used my sheet of lots of different Lego characters, Lego minifigures there, I have one sheet with lots of figures on it. I have a collection of minifigures that are organized according to this sprite sheet. So I'd like to include them in here, even though they're a little bit different. So the types of collections we'll use in Unity, of course, based on the C# collections. collection in C# is a group of several things that are referenced by a single variable. Like we refer to them, a name, an array, a list, a thing. There's some way to have the collection. We refer to it all according to one variable name. Similar to a pride of lions, a colony of ants, a murder of crows. I'm going to say we refer to all these crows, we refer to the murder of crows. Right? The colony of all the ants in there. Right? Important collections, two of the most important collections in C# are lists and arrays. They typically hold kind of a rarefied air. They're important with regards to Unity and how they interact with the Unity interface and editor and so on. The nice thing about them is if they are declared as being public, they will show up in the inspector. I think dictionaries do now as well. That actually has been changed since I first wrote this slide. Dictionaries are a much more special case, more advanced type of thing. So we won't talk too much about dictionaries much, but you've probably seen them in other programming courses you had by now. But we'll focus on lists and arrays. Lists tend to be the more flexible and kind of the more dynamic, more manageable. So we'd like to start there. I like to ask that you try to use both, and I'll give some examples of where I think arrays fit a little bit better than lists, but you can often kind of use them interchangeably because they both are really about maintaining a reference to a bunch of things. So lists are really nice in that you first you ask the question, of course, list of what? Can a list contain anything? Do you need separate or special lists when you want to have a list of strings or a list of floats or whatever it is? Imagine that you had to have a separate data structure for every type of collection of, or every list of things. And of course, that's awful. That would be terrible to do that. Instead, we can use lists for maintaining just about any type of collection, a collection of just about any data type, because it's a generic collection. Now, that's not to say that you can store any data type in any list interchangeably. You like lists to be lists of things of a specific type. There are ways to abstract that if you like, but for now we're going to think of them as being, when you declare a list, you declare the type of things that are in the list. Like the first one is a str list is the name, and it is a list of strings. You might have a go list, which is a list of game objects. So this is the declaration of it. After you declare a list, then you want to do a little bit of initialization to kind of kick things off. It's imagine you have that theoretically you have a list, but you don't have any space to put things on it. It's not haven't spun it up yet. So after you declare your list, you typically spin it up by saying, all right, now this is the start of the list that I want to start working on. Right? So you have a definition for it, for a variable to hold it in, and then you say, okay, here is the instance I'm working with. Right? At that point, then, you can go ahead and use that list, put things into that list. So you then start adding elements to the list using the add method. So if I wanted in here I have a list of strings, I want to add the word or the string hello to my list, I just say string list.add hello. Then I want to add another string, world. So the 0th element would be hello, and the first element would be world. And you can refer to them by their indices, right? List elements are accessed via square brackets. It's going to be the same thing for arrays as well. So if we printed, in the last example, we printed out string list 0, that would give us the hello back, and string list 1 gives us world back. We can use count to get the number of elements currently in the list. And we have things to also help us maintain the list, like string list.clear to empty everything on the list. You can throw the list away, or rather than throw it away, you're clearing out what's on there before you can then go ahead and add items back in again. There are all sorts of different methods on there to help us kind of manage where we add things to the list, how we delete things, how we find things on the list. All these methods act on the string list. Imagine we're using A, B, C, and D. They're all strings, but they're all just a single character in them. So we'll kind of run through and see what happens to each of them. So assuming that the list already has A, B, C, D in it, if I ask for the 0th element, I get back A. If I want to add apple to the list, if I just go ahead and say apple, or add apple, it puts it at the end of the list. Right? If I clear the list then at that point, I would then lose everything that I had on the list. It would go away. Right? The third line down there. We then go ahead and say, all right, well, give me a new list again and reinitialize it with now A, B, C, and D again. We got rid of our apple the hard way by destroying the whole list and starting over again. We can ask for the index of a specific item by what should be in the name. So it'll actually go through and search for an element of that list until it finds one that matches. Right? So if we ask for the index of B, it would return 1. That's the index there. If we ask for the index of Bob or something that doesn't exist in the list, it returns -1. So it says no. We can also do things like insert elements at specific points. So in this case, you want to insert X, it would put it at what would then become the second index, pushing everybody else out. Not out, but, you know, further down the list. You cannot insert past the end of the list, though. This will return an error. You're trying to put something outside the range of known things, right? Everything is always in order. You always have, if you have 6 elements in the list, it's 0, 0, 1, 2, 3, 4, 5. All those always exist. There is no 7. You can't go beyond that. You can't go to -1. You'll get errors there, out of range indices. You can ask to remove an element. It'll remove the first one that it finds of that matches. You can also remove based on the location in the list. In some circumstances, you may find the need to convert between strings and arrays, or excuse me, lists and arrays, because certain Unity functions like to return arrays to you. You want to get an array of components or things like that. You want to store them in a game object list or something like that. So you may need to go back and forth. I guess it's more often that you get an array and you put that into a list. I don't think too many things actually return, too many Unity methods return return lists. Usually they return arrays. All right? So let's talk about arrays. It may not seem it, but arrays, they're a much simpler collection than a list. They are not actually their own data type, but rather a collection of any data type. So they're really about, you know, just managing space as opposed to doing some of the more elaborate things that lists can do. They do, you know, if you look at the code, they may wind up looking very similar though. So imagine we have an array of strings that we declare here. This is how we would declare them. We don't use our generic templated declarations like we did with lists. They're always created with a fixed length, which limits their usefulness. So for example, here, if we wanted an array of 4 strings, after we declared it, we would say a string array equals new string with a subscript of 4, right? So you have to tell it the size. That's because it's just basically a block of memory somewhere that, you know, has one after the other, after the other, after the other in it. It's just a chunk there. So you have to be careful that way. Normally you don't grow or shrink or, you know, they just are that size. You can have uninitialized members of that array, or parts in the array, but you can't kind of create and destroy new elements on the fly, or old elements from the list, or from this array, right? So either of these arrays will only ever have length of 4. This one I implicitly gave it, or wound up giving it a length of 4 because I gave it 4 elements to begin with. So if I give it 4 elements, 6 elements, whatever, it says, okay, that's the number of elements that array is going to have now and forever until you do something extreme, like just throw it away and start another one. Right? They're accessed and assigned via square brackets, so you can kind of do that as opposed to adding and removing and so on. But you access them, say string array 1 equals Bob, Bob gets assigned. There's no pushing, moving things around, and so on, adding and so on. It's really just, you're putting that string at that location. And if you refer to string array one, Bob, that's what you get. It is possible to skip elements in an array, have certain parts that are just null or unassigned. So you might have an array with room for 4 strings, but leave certain ones empty if you wanted. Or even leave gaps in your array where you might have, say, room for 4, but leave nulls in between. Have the 2 strings with nulls in between. Arrays use length instead of count, just to keep you alert. But of course, that's what strings use, because they are collections of characters as opposed to lists as well. Right? So strings have sort of a special relationship to arrays, because once upon a time, when we wanted to use strings, we were just using arrays of characters. Right? That's why they're sort of coupled that way. That's where they all start off. Arrays do have some methods, though. Nowhere near as elaborate as what you can do with lists. So imagine you're operating on that array here, A, B, C, and D. You can print a certain one, you can set a certain one. If you try to access something that's out of range, you get an index out of range. There are some system-level ways to manipulate arrays. So if we get into situations where we want to potentially resize an array, which I said that you really don't do, because what really is happening if you decide to resize an array, unlike a list, it's really just destroying the array, creating a new array, giving a new reference to it. Right? Arrays are really just, like I said, it's optimized to be sort of just a chunk in memory somewhere that keeps track of a finite group. You can convert arrays to lists just by passing in the array to a new list. So if you do get something back from Unity as an array and you want to keep track of a list, you can do that sort of thing. One of the nice things about arrays is that by default you have the support, kind of multi-dimensional support. Right? Arrays can have more than one dimension. So imagine you had a 2D array of strings that was 4 by 4. So then you could start to refer to, say, element 0, 0 as A, 0, 3 as B, 1, 2 as C, and would populate this 4 by 4 array, or 4 by 4, sort of a matrix of elements with lots of blank ones in between. So it's nice for their multi-dimensionality that way. If you print the length, it is still the total length here. In this case, it's 16 because that's how many elements are in there. It doesn't have to do with how many are populated or not. It's really just how much space it has in there. Both lists and arrays can be composed of other lists or arrays. So this is how you can sort of make multi-dimensional lists, because you can have lists of lists, things like that. Right? So even though arrays are more kind of intrinsically multi-dimensional, or can be intrinsically multi-dimensional, you can do some things with lists to get around that as well. Now by jagged, we mean that they may be set up in such a way that you don't have the same number of elements in every row or every, like in this we have rows and columns within our array, or perhaps we have lists of different lengths in our other lists of lists. Ways to do that. I don't think I've had anyone really resort to doing this sort of thing in any other project here, but it's something to be aware of. They're pretty powerful. Now, list your ways. Which to use, when to use which. There are pros and cons to each of them. Lists have flexible length, whereas array length is more difficult to change. Arrays will typically be slightly faster because of their fixed size, You're not traversing a list. There's no pointer management and manipulation in terms of figuring out as you go through. You just say, okay, I can calculate the address of a certain element in there. Boom, get there. You know, it's kind of fixed reference speed. Whereas lists, big long lists, may take extra time to get, you know, further and further things are out in the list, potentially, depending on implementation. These days, probably doesn't factor in as much as it used to. Arrays allow for multi-dimensional indices. Arrays allow empty elements in the middle of a collection. That's one interesting part, right? Because of the fixed size. If you had something like an attractive map of a grid, and you want to position certain things at certain positions, then you might use that. However, in our use, typically, because they take less forethought in terms of designing them out due to their flexible length, lists are attractive when prototyping games, since prototyping requires a lot of flexibility. If you're not sure how many enemies you're going to have, or how many items are going to be on the screen, or how many of this, or how many of that, you know, you just need openness, flexibility. Tend to use lists. Certainly can get by everything in the apple picker using lists, but I recommend you try to manage one thing with lists and one thing with arrays in the apple picker. So there are dictionaries as well. Dictionaries are different in that each element in a dictionary is a key and a value, allowing you to do things like look up elements in the dictionary according to their key as opposed to according to their index. Now we're able to do that in lists by, you know, asking for, you know, an index of bomb, for example, but it's not really optimized to do that, whereas a dictionary is really optimized to this lookup based on the key. So it's more akin to it like a database sort of thing, where you have a key in there and you say, oh, give me, look up the book called Necronomicon, and then you'll find all the, you know, information about your book that has the key Necronomicon. Key could be a string like a username or a really cool book name, or, you know, that sort of thing. The value is the user data. We haven't wound up using them for much stuff. It is useful though, but be aware they used to not appear properly. I think that's fixed now. I think that is fixed now. All right. So any number of objects. List is generally more useful, the most useful. Arrays less flexible, but have their place. If you need some speed, you can't have lists of lists, and so on and so on. All right. And once we get to prefabs, then we'll kind of circle back and start using our lists. I'll mention sprites just briefly in terms of sprite sheets as collections of sprites. So, as an example, in my game here the other day, I had an image, and this is at least, you know, it's not scripted at all. This is really just within. There's no C# equivalent. This is really just how Unity is handling it and dividing up these sprite sheets into sprites that I can then reference, all abstracted through the engine. But I started off with a single bitmap, or a single image that happened to be transparent, has transparency there. And after importing into Unity, you can see the Unity inspector is showing my import settings. When I click an asset in here, like a sprite, you'll see the import settings for that. So in this case, you'll see there's a lot of different ways to potentially import an image. You can use this all sorts of different maps, like normal maps, lighting maps, directional light maps, shadow masks, and so on. But we like to typically start off with sprites, 2Ds, and UI elements. So that's typical image import is just a 2D texture. And the important thing as far as collections go is we told it, yes, this isn't just a single image. This is multiple images. It's a collection of images within, a collection of sprites within a single sprite sheet. I can tell it how to map that. Since it has a resolution, some resolution that it defaults to, it decides, or not defaults to, when it was created at a certain resolution, all bitmaps are. Whoever did, they set the size. I don't know what the size of this was offhand. Let's see. 17, oh, I did it, just a probably cut and paste here. 1702 by 768. So that means, if I think about it, the height of each of these characters is roughly, what, 380 or something like that. 380 high and 1700 divided by 2, 4, 6. So 300 some odd. So this pixels per unit, I could really have said if I wanted each one of those to be 1 unit high, or 1 meter high in the world, and I know that they're about 334. Oh no, 384. So if I set pixels per unit to be about 384, and I'll apply that, you notice it shrunk down immediately. And I'll look in here, and if I move it around, you see, I didn't get it quite right. So this is 1 unit in the world, and by fixing that to say, all right, that's how big it should be. Right? That's the relationship between our resolution of our sprite sheet or any sprite. That's what we use that pixels per unity unit for there. Right, pixels per unit. So I could 350 maybe. Just about there, right? So everybody's 1 meter high. Perfect. Great. We can also do things like say, well, okay, when it scales, if you're going for pixel art, kind of pixels art style games where maybe you don't want things to scale smoothly, you want things to look nice and crunchy and so on. We have ways to set things like that. So right now I'm using bilinear filtering. That means it'll smoothly scale. If I wanted it to be pixelated, I would say no filtering. And in this case, it's pretty reasonably high res, but you can see now he's sort of starting to get a little bit pixely there because it's not doing any smoothing as it scales. So I'm going to go back and say bilinear, and apply that. And you'll now notice it immediately is now smooth no matter what scale he's at. And the other cool thing is no matter what these, because they're all set for the single image there, if I drag in another character, they'll be set at the appropriate height as well. So you set it for the whole image. If I needed to edit anything, I would use the sprite editor, which I can always open up here, the sprite editor. We won't get really into that. We just use the default slicing and automatically generated. This is going to divide it up pretty nicely. It's funny, it even found this little semi-transparent top in the background. It's kind of interesting that it figured that out. This is just enough clearance between here. What it's doing is trying to find areas that are not connected. But it knows it has to create boxes to bound things in, right? So it can't have a mask using just a lasso sort of thing. It just creates a brute force kind of rectangle. So it said, okay, here's an area that's separated by enough, but I need to use those rectangles. So it might not be all that useful to use that back one there because we want it with a chunk of his arm, I think. Maybe. I don't know. Let's see what it did. See how smart it is. So if I drag, where's that little one? Yeah. It has a shoulder in there. Not too great. So that's a flaw. All right. So there's a bit about sprites. So in your games, you're free to use sprites from any source. I'm not going to check to see did you generate your own. Find them from Unity Asset Store, OpenGameArt, itch.io, Game Dev Market, Reddit, GameArt 2D, craftpix.net. I just ask that, of course, everything comply with the same rules of what our behaviors, etiquette, and so on with regards to as set out in the syllabus. No offensive images, nothing that portrays anyone in a bad light, and so on. So otherwise, we're pretty far open with regards to what type of images you use. All right. A cool thing that is also a possibility, sprite sheets don't have to be just individual distinct sprites. You can use them as the foundation for animations as well. So you can have sprite sheets that are flipbook animation type of things, or they can also even be multi-part sprites or sprite atlases, where there are parts that make up a sprite that we can animate pieces of them independently, like this dog spaceship here, or our running snow kid. You do things like that. We'll cover animations later as well. So, introduction to sprites. Now, a real bread and butter piece of Unity development. Different game engines have different mechanisms for this, but usually there's some sort of prefab or template mechanism that you can create an object that is an object that has a set of maybe components, default settings, and set up a certain way, and you store that as an asset that you can then use over and over and over again. That's what a Unity prefab is. It becomes an asset in your library that then may have components associated with it, could have custom components that you wrote, or any Unity built-in component as well. So when you do things like have multiple players in the game, or multiple enemies running around the screen, or parts of a building, for example, you might have X number of cars on the road that are all based on the same prefab, and then you instantiate prefabs as you need them. So prefab, Unity allows you to intuitively create these types of duplicates using what is called a prefab. They're also sort of a clone. They start off being clones, and then you can customize them as you wish. They're called prefabs. A prefab asset allows you to store an asset with all of its properties inside the prefab, and the prefab acts basically as a template that you can then use to create new instances of the same object in that scene or in other scenes. Right? You use it throughout your game. You can also store it and export them and use them in other games, and so on and so on. Right? It's just another asset that you can kind of use in any number of situations. So obvious uses for us now, we're going to be dropping lots of apples from the tree, so it makes sense for us to use prefabs of our dropped items, because we don't know how many they're going to be, and we want them all to have the same behavior, or at least some same starting behavior. The player in this game also manages a couple of different baskets on the bottom, right? The baskets have certain behaviors and so on, so maybe there's going to be a basket prefab. Is there going to be a player prefab? Well, you could create a player prefab. You could really make any object in your game prefab, put it in your asset folder, drag it in, and so on. Anything can really be a prefab. You don't have to use multiples. It just sort of is designed with that in mind, but you can err on the side of having everything as a prefab if you wanted to. Working with prefabs is pretty straightforward. To make a prefab, you just create a game object in your hierarchy, like we've created our game object so far. And then you just drag it into the project window, or the asset window. Boom, it becomes a prefab. Right. So let's try that arduous task here. I'm going to come over here and say, well, all right, I have this apple, and in my scene, I'm going to grab an apple. Apples are huge, so there's an apple over there. And I'm going to add a rigid body 2D, and I'm going to add a circle collider. And let's see, anything else I want to add? Any scripts that I had? Apple mover. Oh, that was the thing that kind of shot things off at an angle. So maybe we'll throw one of those. What was Apple physics? Oh no, that was the one that shot it off. Apple mover. Oh, the Apple mover was to move the enemy. Apple physics was the one that forced it to start off with a little impulse. So that's what we'll do. We'll go to the red apple and we'll add the component and Apple physics. We'll put that one on there as well. All right, so if we play the scene, it will shoot up a little bit in the world and then it'll drop down. And we will create a prefab from that. We just drag it from the hierarchy here. I'm going to recommend that we create a folder and create Apple Picker prefabs. You may want to create an Apple Picker directory that has all of the folders that are specific to this game now. You get into your hierarchy, you can kind of decide, do you want it flat and wide or how deep you want your hierarchy of organization. So we're going to grab red apple and throw that into Apple Picker prefabs. And it has created the prefab here. You'll notice up here, the box next to it now is that kind of little blue box there. So it created a prefab. It is now also noted that in the scene, this is a prefab. It looks, very similar to, nothing much changed really, other than this little icon over here. But if we open it, we see that, yes, it is a prefab, and you can see, look at the parts of it as it's defined as a prefab. Once something is a prefab, you can turn it into its own distinct object or break that connection between this object and the prefab that it was based on. So if you, for some reason, wanted to make it entirely unique, not subject to changes, because as of right now, if I change something in the prefab, like say I came along and said, well, all right, I want apples to be twice as big here, right? I've changed the prefab, and it also changed all the unmodified apples in the scene. Right? So they're still connected. Up here, I could say, if I right-click, check the prefab, I can say, open it in context, in isolation, select it, unpack it completely. So if I unpack it, you'll notice it is no longer a little blue cool box here. And if I come down to this one and I return that to 1 and 1, this one is no longer affected by that because it's not a prefab anymore. So let's delete that one. Now I can modify a prefab that is in the scene, and the values that I set for that are unique to that particular instance of that prefab. Right? So I can sort of instantiate these prefabs by dragging them in and modify their own variables with their own properties. You'll see it has overrides here. Overrides are the things that I have specifically changed about that prefab in that particular instance. You can see that was just the transform. And I think I can even invert that. Erase that. So now it's back to where it was. No longer overridden. Very useful. So we have this prefab, which is an apple that drops down. And things like the apple that are going to be dropped by another or instantiated according to an enemy, bullets, things that are dropped, spawned items, and so on. You typically create them, you drag them into your prefab folder, and then you go and delete the original so that it doesn't exist in the scene just yet. Right? So we kind of hide it for now. So we've created a prefab. It's just simple as create the initial one in the scene, drag it down here. I could have decided, I think I can create a prefab. Can I do that? I've never actually just created one down here. Yeah, I think I could just go ahead and say create 2D. Yeah, create prefab. So I can start with the prefab down here and work on it entirely outside of a scene if I wanted to. I've never actually done it that way, but you could. Some people like to just create things and then push them in the scene later. I like to create one in context, in situ, and then build it from there. So let me delete that one. You can. All right. Oh, no, not my email. All right. So you can unmake a prefab by unpacking it. You can modify prefabs, modify all instances, and so on and so on. So once you have prefabs, you can position them in your scene just by dragging and dropping, putting them wherever you need them, wherever you want them. More powerfully, though, more interestingly, though, is you can instantiate them in script. You can create them on the fly. This is where they really come into their importance, or come into their glory. Instantiating projectile. Shooting an arrow. The arrow is instantiated, it goes off somewhere, and maybe at some point it dies and disappears. But instantiation is one of the key things that we use prefabs for. So we instantiate a prefab, we give the instantiation three things, and there are actually a few more. Instantiate is one of these functions. Many functions are overridden functions or overloaded functions, where there are different versions that you wind up calling, but they're all named instantiate. Right? We'll talk about function overloading and inheritance and object-oriented stuff. We're going to get into that a little bit more detail later on. But for this course, you just sort of have to get a reasonable feeling for it as opposed to really understand the deep down specifics of it. So, like I said, instantiate is a overloaded function, but this is the version of it we'll use a lot. Where we pass it the prefab that we want to instantiate, so we give a template to create a new object from. You can play games on the fly where you can actually accidentally, usually when I've seen this done, is give instantiate an existing object in your scene and have it create another instance of that object even though it wasn't a prefab in the first place. So you can actually do that, and usually that leads to problems. So I highly recommend, at least starting out, use instantiate with a prefab that you have made and put in your asset folder. Work from there, and then we'll get fancier later if you want to. So you tell it what template to use, what prefab to use, where on the screen you want to put it, because it has no default location. And also, you give it a rotation. So you can give it basically an orientation. It's a location and its orientation. Imagine a camera. So we put the camera somewhere in the room and we say, okay, what position is it facing? Right? In the case of our 2D prefabs, we're just going to have a Z rotation, but we're going to have to tell it what that rotation is notice this is not just a 2D function. Right? So when we give it a rotation and the location, we're going to have to give it the 3D version. So it can get a little bit gnarly. And we'll talk about that at the bottom of the slide. So location is the position in the world where the object should appear. Often, if you want to spawn something, like you have our character, our antagonist, our bomber moving across the top of the screen, we would instantiate the bombs or the apples that that character is dropping at the same position as the spawner was, right? So it's halfway through, just use that transform dot position, that's the new position. So we'll just drop it down. Rotation is the rotation of the object in space when it appears. For now, unless you want it to be spinning or doing something special, which maybe we'll eventually do, we want to leave it to a default value. Now, default value is going to be something kind of fancy. This is one of the places where we have to deal with these things, these quaternions. Have I talked about quaternions at all in this class yet? Okay. Um, Volumes and volumes of text have been written about quaternions. Rumor is, the Necronomicon, the book that you're reading, though it's saying for reading, is based on some of the actual books about trying to understand. Well, maybe it is, maybe it isn't. Quaternions are very strange. They're basically using three-dimensional measuring spaces to represent certain types of rotations and so on beyond inter-game programming. But they are an ideal representation of a rotation that prevents kind of weird artifacting when you're trying to move things around and mix rotations and stuff. To water it down, the best way I've come to explain this, imagine a rotation, and in our case, 2D rotation is simple, where you just have an object and you just want to spin it, right? You just have some z rotation at some value from 0 to 360 or 0 to 2 pi, or however you want to think of it. And it just rotates around the z-axis, which points out the center of this thing that, the object that you're spinning, it has at the center, z points out, and you just give rotation. So the z-axis that points out, that is your axis. And the z, the theta, is the amount of rotation that there is around that axis. 90 degrees, quarter of the way around, 180, halfway, and so on and so on, right? What a quaternion is it's a special case of something called an axis angle representation of a rotation. So rather than say the rotation is a combination of x and y and z in their orientations of their origin and so on, instead it says, okay, imagine I have a vector at some arbitrary direction in space. So it can be pointing in any direction, any orientation. And that is the axis that I'm going to rotate around, right? So z would just be, okay, I'm pointing in the z direction and I rotate around. So I have x and y and z, which z happens to be 1 in the z-axis. And then I have a certain number of degrees around that axis that I'm rotating. So I define an angle, I define an axis, and then an angle, which is the rotation around there. So that's axis angle orientation or axis angle notation to represent a rotation. And a quaternion is a slightly special case of that that is sort of further optimized for use in 3D math and optimized so that certain types of transformations just are easier to calculate. So we could spend a whole day on quaternions, but just think of them as being a more powerful way to represent rotations. If we have quaternion identity, that just means, okay, don't worry, it's a unit angle and it has no rotation. Sorry, a unit vector with no rotation around it, so it just means no rotation. Occasionally you may have to say, oh, give me a rotation that's made of an x and a y and a z, instead of Euler angles, convert that to a quaternion and say, okay, now rotate this according to this quaternion. So there are ways to go back and forth between Euler notation, which you're probably familiar with, right, instead of x and y and z rotations. But quaternions are confusing, but your friend. But for now, just know they exist, know the buzzwords axis angle and efficiency, etc., and that you may have conversion. So we have a position, we have an orientation, or position and rotation. Away you go. That will create it there in that position. Now, this is one of the overloaded versions of that function. So you notice there's another instantiate here, same exact name. You pass it the prefab you want to build. And this is a little bit different. It says, well, okay, instead of giving it its own unique position and identity, you give it this transform. Now, we usually think of transform as being the transformation of an object, its location, its orientation, its space, and so on. However, Unity has this one shortcut that you eventually get used to, whereas since every game object has a transform, you can also refer to that game object by its transform. So this sort of effectively means this is belonging to this game object or this transform that's on this game object, which means it becomes a child of this game object. So it's kind of stuck to it exactly where it is with its orientation and so on. Right? That could be fancy if you want to say build a wall. Right? You want to build a whole bunch of bricks that all belong to a building. Right? You can start off by saying, all right, you all belong to there. Another use of this that I recommend, imagine we have the player, which moves on the screen on the bottom. And we have 3 baskets that the player can have at any time. Maybe they start off with 3, maybe they can have 5, maybe they wind up with 0. So they have some number of baskets between 0 and 5. And we want those baskets to depend on the location of the player, which the player really doesn't look like anything. The player is just a thing that moves on the bottom of the screen. So we may instantiate baskets that belong to the player. So they move with the player, they become part of the hierarchy. There are other ways to kind of sneak things into the hierarchy, but if you're trying to do it dynamically, this is one way to do it as you're building an object, or as you're building or instantiating a prefab. So keep that in mind. You can script them in all sorts of different ways. You can have offsets. You can use your friends, the loops. Imagine having 2 nested loops, one that gets iterated over 4 times, and one gets iterated over 2, 4, 6, 8, 10 times. You create a wall of bricks, right? Just keep changing their location, build them, stack them on top of one another. They would all be created. If you created them all according to the transform that they're on top, then they might all be children, and they all move as a unit, or you might create them independently, and then you can throw a ball through them, and they would all blast and fall apart independently. Up to you on that. So that is the quick introduction to prefabs. So let me do a quick example using that. So fortunately here, I think, if I grab this guy, use him up here, and I had Apple movement, if all goes well. All right, here's my antagonist across the top of the screen. Script was intact. Thankfully, Unity, you save scripts all the time, so even if Unity crashes, the scripts are already there. You may lose the rest of the project, which I'll save right now. Save. Publishing, get that out of the way. See, not painful, done. Now I don't have to worry about it being lost anymore. So in this object that has this Apple movement, I'm going to call this our antagonist. Or better yet, let's just call him the crook, because that's fewer things to deal with. And this one, I'm going to delete. So we have the player, we have the crook, and we have, down in prefabs, we have this red apple. So let's go to the crook, and for now, this apple movement is rapidly becoming, or might become, crook behavior. Probably would have been a better one to call it. The crook knows how to move here, and we want to give the crook the ability to drop apples, to instantiate these apples. So first thing is I should say, well, serialize field. Game object, whoops. Apple prefab. Now if I save that, we'll see immediately we'll have our apple prefab available over here. What happened? No, not player controller, crook, there we go. Apple prefab, none. So we'll go down here, we'll go to there, and we'll drag this. So now the crook knows about red apples. And let's go back to the crook. And we have to decide now, okay, how does the crook decide to drop apples? Well, just like the crook changes direction, maybe I create something called drop apple. And I'm going to set up another serialized field, which is going to be a float, which is going to be, I'm going to call it drop rate. Or, no, let's forget, drop interval. Give it a default value of 2. Pretty slow. So I'm going to say every 2 seconds I want you to drop an apple. So hit a drop interval of 2, and at start, I'm going to say invoke drop apple, and I'm going to use drop interval. And down here, I'm going to do the same. And for now, I'm going to keep it steady. Now, I'm not going to change speed. And now I'm going to get rid of my cancel invokes because I want to accidentally cancel. If I say cancel invoke without saying which one, I'll cancel both of them and I'll wind up like losing out. So we'll leave that for now. So we need to figure out how to drop the apples now. We're dropping into that interval, and we'll just go ahead, instantiate. Nope, not that. Instantiate, and we're going to use the apple prefab, and we'll say, okay, transform position and Quaternion identity. All right. So that may not be the best behavior in the world. And every so often, it will launch one and they'll collide. So apples can collide with one another. It's kind of a... Let's do this. Let's say we're going to go to our apples, and I'm going to remove that apple physics. Apple physics was no good. Or I'll disable it at least. All right, so it's dropping apples. You'll notice there, red apple clone, and it's going to keep creating them, and they're going to fall infinitely, and they're going to never go away. So if we were to zoom out far enough, we'd see that there are infinite space. There is infinite space, or close to it. Really big space that all these apples can drop down into and just exist forever. So we have to then figure out, okay, how do we destroy apples? We know how to create them, how do we destroy them? And believe it or not, there's a function called destroy. You can give it any game object, destroy that, game object and it'll destroy it. So the next challenge is to say, okay, at what point do you destroy these apples? When the player catches the apple, you destroy it. When the apple exceeds some boundary at the bottom of the screen, that would be another instance. You could put a collider. You could have a collider across the bottom of the screen, and the moment it hits that collider, they cease to exist. So we have lots and lots of choices. Let's look at we'll finish up with some specifications. The last bit of here. All right. So, project 2, the apple picker. The enemy moves left and right across the top of the screen. You can use transform, translate, or position plus equals, or any of the methods we've used so far. Enemy drops objects at random, perhaps. Right now it's dropping them at a regular interval, but it is moving randomly. Use instantiation of prefabs and rigid body 2D for movement. We've already done that. Now, here's where it starts to get a little interesting. We want to keep track of the apples in a list. That's my recommended way to do it. Originally the book that we used to use, the text, used tags, and then it would destroy everything with that tag, and I think it's an inefficient way to do it, and this is a better exercise. So you may see other versions out there that do weird things. But we want to do this to say, okay, every time you instantiate an apple, you keep track of it in a list. Why? Well, because if the player misses an apple and it gets past the player, we want to destroy all the apples that are on the screen. We want to destroy all the game objects that are apples. So if we have them in a list, we can easily traverse the list and delete each one of them and manage it on the list. We can even go so far as to automatically have those apples put themselves in that list when they're created. We can have them automatically destroy the list when any one apple hits the ground. Right? So they have certain behaviors that they form as a group, so we can use the list to kind of help us do that. So what happens to one happens to all, and so on. Right? So that's where we're going to put them in a list. The enemy changes direction if it hits the edge of the screen playfield based on a decision, not a collision. We did that already, actually. Enemy randomly changes direction between edges on the screen using random. We already did that even. Enemy should incrementally speed up motion and apple dropping over the course of play. So things like the speed variable, that drop interval variable, it's really just a matter of deciding, okay, how are you going to tweak that? Over what amount of time is that going to increase? Is it going to increase every time it changes direction? Is it going to increase every time it drops an apple? Decreases that interval, multiplies it by 0.99, so reduce it by the interval by 1% each time. You can come up with your own kind of decision on that. The player is to have 3 baskets to catch items, demonstrate how to use an array. So used to be strictly 3, then I added some bonus options to say, well, if the player hits the high score, maybe you should give them, you can have up to 5 baskets, but you start off with 3. So we create an array that has up to 5 items in it, 2 of them empty, 3 of them pre-populated with baskets, and then you have to, use that in that array, and you can use that for all sorts of helpful things. They say, okay, depending on what order they are, what position they are in that array, you can figure out, oh, okay, I need to delete the one that's at the top. That is at the highest position in the array, or maybe they're inverted, or they're shown. So you do some things like that. So the player has 3 baskets to catch the items, demonstrate how to use an array. The player basket movement is controlled by the mouse. We did a pretty good demonstration of that. Now we get into scoring. If the player catches an item, the score increases. We're going to do that with on collision enter 2D. We're going to talk about collisions next time. If the player misses an item, the player loses a basket, and all apples that are in flight or in midair also get destroyed. You might also just decide, okay, you should temporarily stop dropping, give the player a chance to pause, right? So a little bit of opportunity for game design, for juiciness in here. I'd say, all right, it's not just mechanical. Figure out how that happens. So if the player misses an item, the player loses the basket, all the apples are destroyed. The game ends when all 3 baskets are lost. We also want to use player preferences to save and load the high score. So every time the game is played, even though you shut down your computer and so on, it will remember the high score for next time. We'll talk about ways to kind of reset that and so on, but it's a simple way to do kind of save player preferences. It's not meant to be a really elaborate serialization or storage system, but simple bits of data will do that. Include a start scene and a game over scene. So once the player chooses that, it really shouldn't go directly into the game. It might be this is how the game works, especially if there's any sort of mechanics like, oh, these are the items to catch, these are the items to miss, these are the items, this is how things are going to go, and then launch the game. And when things splat, say, oh, congratulations, you did great, or wow, that's too bad, whatever. So your scene usage on that, potential scene usage on there. And then you want sounds. So when it throws an apple out there, or throws whatever it is, or sneezes, or whatever the noise, appropriate noise, right? Those things should happen. When it hits a basket, it should have a unique sound. When it hits the ground, it should have a unique sound. Maybe it has music the whole time it plays. All right. So those are the general rules. Bonus ideas. Right? There's lots of different opportunities. Use singletons to manage a dropped item list within the dropped item class automatically. Drop multiple items for different high scores. Drop items that should be avoided. Reward high score by restoring a life. Delay the destruction of dropped items in sequence, like kaboom. That's trickier than it sounds. So if you miss an item, it doesn't just delete all of them. It goes boom, 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 all the way up to the top. So with a delay as they kind of sizzle across. Multiple enemies. So what happens if you have 2 trees? How does that work? Multiple players. You do that as well. Have 2 different people. One person uses the mouse, the other person uses the keyboard. Want to get real fancy. Power-ups that change the basket behavior. Fire a weapon, deploy a shield, destroy all the dropped items. That sort of thing as well. Lots of room. Hints as far as the number of scripts. Ballpark, typically we have a player behavior script, might be the game manager script, the enemy behavior, the basket behavior, the dropped item behavior. Right? Those are really the dynamic elements in the game. Food for thought, some architectural ideas. So if you want to refer back to this, I will occasionally sprinkle pseudocode in some of the lecture notes so that you might refer back to it. So maybe this is how the player behavior is set up, things that have to be taken care of. The player needs to know about the basket prefab. It has some number of baskets, and it's maintaining the current number of lives it has and the offset in between the baskets. It has some mechanism for losing a basket. It has some mechanism for storing the score. Why do I store the score in the player as opposed to storing it just in a game manager? Well, maybe we have multiple players, and each player needs to have their own score. Possibility. Maybe there's the tree behavior or crook behavior. It has a speed that it goes at, a drop interval that it drops at. It knows about the edges of the screen. It knows about the prefab for the things it's dropping. It knows how to accelerate, how fast it's dropping, or how fast it's moving. When is it changing direction? When is it dropping things? Like we just had our apple drop here, here. And maybe if things die, it has to pause for a second. Maybe. This is that kind of fancy version, or food for thought on having the mines or the apples or whatever they are that are dropped, that have their behavior. They could use potentially a shared or static list across all of them to say the group that they belong to. And maybe they are on enable and on disable. Those are when things are created and destroyed automatically by Unity. Maybe that's when they're put in. That's where we can sort of do some list management. And then, of course, the basket, we just want to know what happens when something hits the basket. and maybe you have the scene loader. That you already have pretty much from the lobby. So there's some ideas for the project scripts, right? You shouldn't have dozens of scripts. But here, it pretty much almost becomes a one-to-one kind of thing for the basic things, at least the things that have that can't be managed by other things, because you have to sort of decide: is it the apple that hits the basket, or is it the basket that hits the apple? We'll talk about collisions and how that, what is hitting what, and who can manage those relationships next time. So that's it for today. Ending a little bit early. If anyone has any questions, if not, or yes?
Is just using a static variable like that count as a singleton?
No, this actually wouldn't. That wouldn't really be a singleton, because it doesn't do any sort of management of it. Yeah, that was. I think my slides are a little bit out of sync on those two things. That's really just using a static member.
What's the point of having array baskets instead of having one basket and keep track of the number of lives that both are missing?
Well, you mean having the graphically? It's
keeping 3 instances of the basket object around.
Well, I'll show you an example of that. What I've done is I've done some things where you have like a configurable version where you have, like, say, basket here, and they all kind of move simultaneously, and then all these collisions that activate. So you can set up kind of more elaborate, imagine a ship or even a character that can catch one thing in one hand or another hand. So you can get a little bit fancier with it. I like to, instead of just having a basket at the bottom and 3 lives and just keeping track of it, it's the classic game has 3, so or has multiple ones, and each time you lose one, it's it's fun to have the visual piece of it as opposed to a life counter in the corner, if that's what you're sort of asking. So it's part of the challenge. Imagine having a ship that was damageable or something like that, where you had some progressive damage on it, so you could have a snowman, and every time the snowman got hit by something, one piece of the snowman would disappear. Think of the baskets as being that sort of thing as well. So that's just a design point. But being able to manage it, using the, I like to use arrays there, because then you can kind of figure out, okay, if you want to, you can figure out which one got hit, the things you can do like that. And then also they intrinsically know something about the height that they're at. Right, so you can, if you need to destroy one, you can say, okay, the topmost one is at this position, and so on. Could you do it with both? You could do it really any number of different ways, but I just like to make sure people understand how to use arrays and how to use lists. So, feel free if you've got something really specific you want to do with it that is above and beyond that. I'm open to changes on that. Does that kind of answer it?
Yes.
Okay. Any other questions? All right. Very good. Have a great weekend. See everybody on Monday. Probably see you on Discord if you were hanging around there as well. There's one weird thing that you need to sort of set. All right, cool. For some reason, the default export in WebGL in Unity sometimes includes it always includes some type of compression. Sometimes it includes gzip. Sometimes it includes this other thing called Brotli, B-R-O-T-L-I, and which, if you use the Brotli compression, it generally has that behavior on itch.io for some weird reason. Somehow they don't support it. So if you go to